chances that happen? And based on that, like we don't really need to design something like super complicated, or make it like over design. Because a lot of time people tend to over design things. So we just have to figure the exact minimum, and that led us to use a lot of different technologies. You might be interested how we talk to it. So the helicopter actually used Zigbee, which is actually just like Bluetooth in your phone. It's the same exact frequency. Helicopter talk to the rover, and the rover can talk to either directly to Earth, or there's two orbital satellites around the Mars. Like when Mars not facing us, you can talk. The rover can talk to the orbital satellites and could tap back to us to Earth using the Deep Space Network, which is it's an international space communication run by NASA. Anybody have questions? Feel free to raise your hand.
Yeah, actually, I was going to ask about battery. So, which kind of battery system you use? Which element based or? Do you have?
Yeah, sure. I can get to that. So, I might have a picture.
Okay.
So we use actually 18650 battery, which is the same battery. It's, originally I think they're designed by Panasonic for laptops. So they basically a cylindrical battery. That's so this is actually inside of the motor. So this is actually the motor we designed. This is actually hand wind. I don't know a lot of people hear space science, so they don't care about this electronic stuff. But so this is to make this happen, I'm gonna simply put it together. So this is actually the rotor part of the motor, and this is actually the top part of the motor with the electronic board. We had to make them extremely so small. We had to customize this. This actually, I hand wind this. It's actually 6, you can count them 6 turns. So this is actually one of the latest feature we give the helicopter. So originally when we designed the helicopter, we had to usually designate a landing site. But then as we start getting more picture and learning Mars, we actually figure out this is actually where it can land. So as all the time it's flying now, it's actually you can always find a location where it can land. So it doesn't have to be pre-programmed. Yeah, it's just, this is the cameras we use. There's 2 cameras used on the bottom, one for navigation and one for this. And they're just basically cell phone grade cameras. So what's next for the helicopter? We're actually now working on 3 new helicopters that are going to be sent to Mars. And one of them they're going to be used for the Mars return sample. They're actually going to design the same helicopter with an arm, and they're actually going to collect these samples to bring back to Earth. But not the helicopter, just we figure out they're the rockets will probably be coming back. So why do I work on space? I think space is extremely special. I always think about our ancient, ancient scholars. Every time, when you read to the old scholars back in, 1,000 years ago, a lot of them actually are astronomers. It's so you find, even when you read about Khwarizmi, you read about Benzina. A lot of them, he's a doctor, but at the same time he's an astronomer. I was always wonder why. I remember myself when I walked on the beach when I was a kid. When I was thinking about my future, I always looked up to the sky. I looked at the stars. The stars give us hope. They make us look further into the future. When we work on space, it's when I look at space from Earth, look at Earth from space, you can notice that Earth is one place. You don't see the borders, you don't see languages, we just see one place and make us bring unity together. So these are the things that really make me think about why I need to work in space. Why is it even important to work in a helicopter? See, we could do research and development, we could do research for the sake of research, but we don't really have an absolute goal. But the challenge of reaching somewhere far is actually make that goal have a purpose. And make us actually come up with so much technologies. A lot of the technology we use today, whether it's cell phones, GPS, solar panels, batteries, we all invented them for space. because like we have a purpose to like, when we try to go to the moon, we have to push the technology limit to be able to achieve that. And a lot of that come back to us. I mean, and that's what made me like, originally I started working on alternative energies that, like I think it make our Earth a lot better. But now I'm working a lot of this stuff for space. So actually, we still do not have solar plane flying on Earth, but we have solar plane running on Mars. So I actually want to leave time for questions, and I could go back to any slide.
So, are you coming to an end?
Maybe I will go back to slide, but you
This
can
project is wonderful, but I'd like to learn what's the spatial benefit of this project? What did you learn from this one?
So we prove we can fly on Mars, and then we collect a lot of the data from like flying, I think number one from flight, from aeronautics, aerospace engineering, we learn about flight control and dynamics, because that actually was one of the biggest challenges. When we first flew the first small helicopter, everybody overlooked that you need a plane that can have very fast reactions. So, to close the loop. And, I think from flying perspective, we learned that. We learned we actually could fly on like 1% atmosphere. And we also a lot of this control, the data we got from the control, they're currently being studied and being researched, like how to advance even flight on Earth. We have not discovered anything on Mars yet, but
No, I cannot expect such a great discovery, but I expect some contribution to our technology, for example.
Yeah, just like the advance, actually, there's a lot of areas we could not reach with the rover. So, which is actually now, that's what made NASA actually think about sending more helicopter, because they're actually a lot cheaper to make than actually a rover. And also, you got to expand the area of reach. So that's was really critical to us. A helicopter, the helicopter on Mars, right now the helicopter covered much more land than the rover did. A helicopter in a day, you could if you just go up to 15 meters, you can have coverage of so much before, so you can decide what direction to go. And the reason, what they discovered in the past rovers, Spirit and Opportunity, and we lost both of them, and they lived a lot longer than they're supposed to. You can drive in a certain direction, but we don't really know. We don't really have the exact, topography of the surface, So you could drive for 6 months, and you find yourself at the edge of the cliff, and you're trying to get to the valley, and you will never get to the valley, And that was the problem, in a lot of the Spirit and Opportunity. Even I think Opportunity ran for almost 9 years. But still, every time it was trying to get to, they were trying to spend years trying to get to a specific location. If they had a helicopter with it, they would have went up as here is a route, we'll map a route for you. Because the now is actually, in the beginning, and that's why NASA expanded the program from only the first flight, because we only were supposed to prove flight as a technology demonstrator, but after that to become a scout, so it's the rover scout. So they'll take the picture, send them to the rover, and actually, or send them back to Earth, and then we'll be like, what, I think we should send the rover this way. So it actually is becoming a guide to the rover.
Actually, kind of similar thing. I was wondering whether the resolution of the camera on board the helicopter, does it help us something beyond being a scout to the rover, or is it the quality of the images? Are they good enough to actually
Yeah, I think
learn something on the surface properties? I don't know.
Yeah, so it has actually two cameras. One is only 870, about 870, which is not even less than 1 megapixel. That's the black and white one. And there is a color one that's about 13 megapixel. You could actually see a lot of the helicopter pictures online. For looking at topography, they're actually more than enough.
Yeah.
But this is also because we made this, so this was not designed for exploration, it was designed for technology demonstrator. But it does actually provide us a lot of.
So in principle, you can put maybe next time, I don't know, an infrared camera or something like that to
Yes. It does actually have infrared. The camera on that it does have infrared. So the one used for navigation, it does have infrared.
Oh.
So another question, it's maybe not so technical, but you mentioned about some challenging parts of, in terms of electronics, but what was the most challenging part? What, was it temperature or just
I
for
think
you?
people are the most challenging part. No, so temperature was really important because when I first, because like literally every single time I work on something, it's like, oh no, you cannot do this. So this is the people, like, because, I'm using, so like this was my argument, like I cannot, we had a big argument between like putting, I'll give you an example. Yeah, so like, they're actually on the motor control, so, because this is, so we had to, like for the temperature was a big challenge where we locate this, because everybody wanted things in the warm box, but it's like we can heat things up so they can be at like, negative 25 degrees C, similar to Earth. But then the problem was like, oh, but this is once you fly, start making a lot of heat, then how are we gonna get heat out of the box? Because now we're keeping the heat inside the box, so then we have a different problem. So, so this is like one of the challenges, like how to make this thing outside, So then it's like, okay, if we do this, even like deciding on the wires, because this wire was like, they're gonna transfer the heat inside of the box. So we made the wire like 1 meter long and we just make a big loop so if the heat does not get inside. The weight, I think the weight is number one, because to achieve flight, I think originally they said we want 1 kilogram. So they come to me and they're like, hey, can you design this 5 grams? And I was like,
So they had a limit beforehand.
no, yeah, because no, we came up with the number. It's like, to achieve flight, like to carry like 1 kilogram, you need this much prop. I mean, this is physics, like you can calculate this, but then it's like, okay, so we can calculate a theoretical airplane, but can we manufacture it, So that's where the challenge is. We have over.
I have a personal problem. First of all, I am in a project about Mars, and we research about Mars colonization, but it's a mostly a architect project. But you know the Mars and you searched. So, have you any idea about Mars colonization for cities, for all humans?
Yeah, I mean, I have my own opinion, but we live in the most beautiful planet in the entire galaxy we know of. I mean, we have, we hear about, Alpha Centauri, then we find out that it's actually not inhabitable. But so, I mean, yes, we could have a colony. We could have a research colony. Are we gonna move there as a human being? I mean, unless nature change. When I start seeing people moving to the Sahara Desert, living in, Antarctica, by choice, I would think people will go move by choice to Mars. But I mean, the difference between day and night, and the warmest day on Mars is about 140 degrees C. So it's like, you have to always be prepared, to have 5 extra jackets, But, so, and that's made even the electronics so challenging, because we could not, like I said, like, not only we had to heat it up, but we had to worry about if it gets hot, like how to stay cool. So that actually affected even life. I know there is plans, I work with Blue Origin. Blue Origin is our planet Earth, right? And we're all about like becoming a multi-planetary species. I think it will be there will be like limitation, but I think we would probably, I would see in our lifetime we'd have colony on the moon and Mars. For research purposes, just for, I don't think it would be very big, because it costs a lot.
I have a question. So you say that in order to make your helicopter fly on Mars, it had to be very light. So this is a feasibility question for making something functional in the future. So if there is this colonization happens to be, somehow after 50 years or something, you need a really functional helicopter to carry something, for example, or to struggle against the conditions and complete some missions. For that, you will have to have a bigger device and a bigger engine. Do you think that, you can succeed that too? If the weight increases?
Yeah, the thing is, like I said, like if we go back to the Wright brother moment, they made a plane, flew for 14 seconds the first flight. So I think we're ahead of them. And now 100 years later, we can see airplanes. I actually, every time I fly, I walk out in the plane, I was like, I cannot believe I'm so stable, I'm walking on air. Because literally, we're walking on air. So, yeah, we just had to prove it, and I think we're already building 3 helicopters similar to it. And also there's another project, which is like an 8-rotor helicopter, which is a lot bigger, to actually serve as a possible replacement for the rover. The thing is, are we really going to be able to replace the rover? I don't know, because we need a lot of equipment, so you might still have to have both. Because, you cannot carry like drills and a lot of mining equipment on a helicopter can handle much work.
What about the season in atmosphere to operate this helicopter? The season, which one?
Yeah, so it's a
Very important because it
Yes.
depends directly the weather condition,
Uh-huh.
especially the wind.
Yeah, I didn't cover that. So there is wind on Mars, and actually it helps us a lot. Actually there's a lot of dust devils. But when we designed the helicopter, so we designed it to operate actually in the late spring. So we were really scared because we were so late, and actually flying it. We landed in February, and then we're running out of the winter of the spring, because spring is more mild, which means you have more air. So after when we got to May, June on Earth, and then after 1 month we fly, we actually it's got warm up on Mars. So when it warmed up on Mars, the air density got lower. So we had to do a provision. We actually increased the helicopter speed from 2,500 RPM to 2,800 RPM to be able to fly through the summer, which was also outside of the design limit of the helicopter. And after that, the helicopter, I guess we already went through 2 Mars years, so we actually went through all the seasons. And the absolute cold winter days, it actually we put it into sleep mode. And because we don't even know if we have enough access to the sun. So we actually, even to make this happen, we actually decided to actually cool it to -4, warm it to -4 instead of 25, so it will last several days as if we didn't have enough charge. And all of this information we actually learned because we didn't know originally, so we only were planning to fly it during, the spring. And then we figured we literally thought we would not survive the first winter. And actually we lost communication with the helicopter for about 60 days at one point. We thought it was frozen. But and then when the rover got closer, apparently it was behind us because we didn't know where it landed. And then we actually ended up finding it back. It was after the 59th flight. We thought it was dead. I thought it was gone. But it's still actually functional.
Did you tell about how did you land these devices on the rover and helicopter on Mars? Did I miss it?
I didn't really talk about it, but actually it was in the 58. I'll play the video, I'll talk about it again. But I didn't really, I wasn't sure how we're doing on time, so I have to rush this. So this, you'd see it actually landing. So, the rover landed on the moon and then actually was attached to the bottom of the rover. I remember every day we'd move one leg. We get the data, because you have to sit 4 hours, we'd move the next leg, It was a really long process, and then the rover moved away and it was sitting there. That was February 21st. Until we flew, it was already April, so. Because even in the beginning, the rover team, they didn't care about us, It's hey, this is not important, we need to make sure the rover is functional. The rover at any time was willing to basically leave the helicopter because, the rover mission was a $1.4 billion mission, and that's really why we said going to Mars for the rover. The helicopter was just an extra toy. Literally just a toy. Does that answer your question?
Yeah.
But, I have, you can see a lot of pictures of that. You can barely see it here, I can actually pause on it. But this is how it actually got into. So, we just use a rocket, so, see, this is when it dropped the first 2 legs, so this is the rover. So, so the most dangerous part of the mission was actually when you go down and land on the Mars atmosphere, they call it the, 7 minutes of terror, you know, I mean, that's what, and because like we could lose the mission. A lot of time you lose the mission during landing. I mean, the Russians lost their mission on during landing. So, and we lost one mission during landing because an error. Some engineers did the calculation in millimeters and some used the imperial system. And we actually ended up losing a mission because of that, because we had two different engineering teams, one used metric and one used imperial system. So,
How many helicopters did you produce?
total of 3. Yeah, one for the testing, one for validation, and one on Mars. So,
Is there anything which did not match while you were simulating in your, the atmosphere of Mars, in your workshop and in real atmosphere on Mars?
no, I mean, yeah, I get actually impressed by, space scientists, and sometimes like a lot of the numbers they say is actually correct. I have no idea, but how can we actually measure the atmosphere on Mars, and so a lot of that is based on studies, and some testing. The data is very limited. I mean, now we're making missions to Saturn, and people have ideas about the atmosphere there, and that's all thanks to space scientists, and physicists. But, because we assume these numbers are correct, so there's a lot of assumptions, and that's why I take everybody. It does not take just an engineer who built it, take the scientist, and then like, based on this, we actually validate this data. This is another thing I think you asked earlier about what do we really gain. We actually proved that the air density is like so small, and it's actually the number were correct. And all our because everything is approximation. I mean, everything is perfect. I mean, even when we say the galaxy is about 13.8 billion years, I mean, is it really? Right?
On the picture, the helicopter seems very small piece if you compare the rover.
Mm-hmm.
It's very interesting for us.
Yeah, it is. Because, next helicopter would be bigger. I mean, I had a picture next to me, so to give you that's the exact size of it. I mean, this is the size of the helicopter. It's a lot bigger than any drone on Earth. I mean, 1.2 meters wide. I mean, this thing weighed about 1.8 kilograms. This is actually early on before we even built the computer, so that's why the wires are here. But usually the wires go inside. I'm sorry, what was that? Yes. 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 Yes, so no, we have everything about the helicopter actually. So everything, like, one of the best thing work for NASA, which is I cannot talk about most of my work. Sorry. I can talk about most of the work for NASA. So I mean, NASA does release everything. I mean, this is actually a 3D model. So you can actually, if somebody you could download everything. So this is actually a 3D model of the helicopter. So, but yeah, you can find pictures, all the pictures. The release picture with raw format, with like full size. You can download any compression you really want. The videos, pictures, even like I said, even we have like this 3D step file of the helicopter you can actually download. But does that answer your question?
Actually not. I want to learn helicopter download as data. How to download data? Digital elevation. Do you know digital elevation model or stereo?
No, not. But I'm sure you can check the website. They might have, yeah. You can download the step file. You can use in other software. Because actually, I use this one to make 3D print. To print actually the helicopter. You had a question?
Yes. Do you read the news? We are going to go space and ISS to moon
Mm-hmm.
from Turkey.
Yes.
What are you think about our space mission, if you read?
You're sending a new astronaut to.
Yeah. So I mean, yeah, it seems like everybody goes to the ISS. Yeah, I think it's a great mission. We do a lot of studies in space. Is the microgravity study. I think allow us to study a lot of things. So I think it's a great. It's a great to send people. I know many countries recently sent astronauts to the space station. So it's part of participating on this bigger. I always thought I'm actually not disappointed now, but because of all the problems between Russia and the US, after all these years of like space collaboration, international collaboration is good, so that's one aspect, so the International Space Station is probably near its end of life. I don't even know how much longer it will be there, but, we are working actually on a new replacement for the International Space Station. It's called Blue Reef. So, but I think it would be great for Turkey, to participate, in a lot of these space programs. I do think isn't Turkey part of Artemis program?
No.
I'm not sure. I think
No.
it might be,
No, we are not in.
No?
No.
Does that answer your question?
Good question. Should be like this one. When will the woman to go to the Mars after this helicopter experiment? Maybe the time is shorter than before, or no any difference. What do you think about it?
For man to the moon, man to the Mars. I think
The
10
goal,
years.
the goal question.
I think maybe 10 years. Because now we have, so it's not really, NASA does not have any missions for the Mars, but SpaceX does. So they're planning on it, and that's their goal. So, so I think 10 years, because even the Artemis program. So like we want to go to the moon, build a base there, and then we go from the moon to Mars. So that's part of the Artemis program. That's the plan for the NASA.
Thank you very much for the presentation.